Helioseismology. First, let's get some basic vocabulary out of the way. Solar means sun. Waves are periodic disturbances of the particles of a substance which may be propagated without net movement of the particles, such as the passage of undulating motion, heat, or sound, or those things in the ocean that could kill you. Helioseismology is the study of the structure and dynamic of the sun through its oscillations. The oscillations of the sun are similar to wave pools at water parks. However, we can't swim on the sun or in it. It's too hot and you'll get crispy, like the weather during a Texas summer. So basically what happens to figure out the sun's oscillations is to use fancy science instruments that use fancy technology to measure the up and down movement of the waves through a series of complicated steps inside of the sun. This is similar to how we measure things like seismic waves of earthquakes under the surface of the Earth. These oscillations last on average 5 minutes each and are stronger closer to the core of the sun than on the outer edges of the sun, which is also like wave pools. The closer to the source, the more fun you'll have. There are 3 different types of waves that are measured inside of the sun. The first one is acoustic, which bounces off one another in a time frame of about 2 hours. The next one is gravity, which is from the center of the sun and has similar properties to how the Earth core acts. And surface gravity is the last type of wave, which is similar to what we feel when we are on the crust of the Earth. And no, none of these can be found in a water park. I've looked. Not one source in the sun generates the solar seismic waves, unlike wave pools where there is only one source. It comes from all over the sun's interior. However, the convective region causes the solar waves that we observe with our fancy science instruments. Sound waves are generated and trapped inside of the sun. These waves are produced by pressure fluctuations in the agitated convective motions of the sun's interior. As they move closer to the surface, the sound waves reflect on the sun's surface. A similar thing would be when you scream underwater and someone else can hear you. The sound waves travel through the sun, causing them to keep going until they die out. It's just the sun's sound waves are more powerful than our squeaky kitten ones. Inward moving waves, or what I like to call the undertow waves, are refracted by the increase of the speed of sound as the temperature increases. The trapped sound waves are what makes the sun vibrate in different patterns. However, the frequencies are so low the human ear cannot hear them. To even hear them, the scientists sped up the waves 42,000 times and compressed 40 days of vibrations into a few seconds. They might be powerful, but we just can't hear them without the help of science. Thanks, science. Sound waves and the modes of vibrations they produce can be used to probe the interior of the sun the same way that geologists use seismic waves from earthquakes to probe the inside of the Earth. This is because the sound waves gives us an idea about what's happening in the sun, and without them we would need to find other ways to look inside of the sun, and it wouldn't be with a telescope. The solar model is a stellar structure and evolution that are applied to our sun. Some of these models describe the chemical composition, density, luminosity, mass, pressure, and temperature at different depths of the sun interior. The solar model is the best method for verifying those theories and for understanding the structure and interior process within a star, because apparently we can't look directly into the sun to see this stuff because our eyes are weak. Even though the sun is about 93 million miles away, you should still care about helioseismology, because it sounds cool and it helps us know what is going on inside of our sun. And that's important to better understanding the universe around us and our very own planet. Plus, the sun is a giant fiery ball of death that could literally kill us if we are not careful and paying attention to it.